Hello and welcome to ThePrint. This is Akanksha Mishra and you're watching Scientifix, where I will be taking you through this week's top science news from across the world. Our first story today is about a recent discovery by Harvard University astrophysicists who found an atmosphere around a rocky Earth-like planet that is within the habitable zone of a star. This is the first time that we've found this particular combination on a planet, and it could change how we see the habitability of our universe's celestial objects. The scientists, using Weinert spectrograph at Chile's Magellan Observatory, found helium escaping from the atmosphere of LHS 1140b planet. It's a rocky exoplanet that's located about 48 light years away from Earth, and it orbits a red dwarf star at a distance that scientists believe makes it possible for there to be liquid water on the planet. The researchers said that the atmosphere has likely survived for more than 3 billion years, making LSH 1140b a prime target for future studies of its atmospheric composition, possible oceans, and overall habitability. Next up, a study by the University of Reading found that cleaning up air pollution worldwide could boost India's monsoon rainfall significantly more than just regional pollution control. The study is based on the underlying principle that aerosols, which contribute to air pollution, also reduce the amount of sunlight that reaches the land's surface. The sunlight is what heats up the land faster than the ocean, and it creates a low pressure area that drags in monsoon winds that cause rainfall. When aerosols increase and block the sunlight, they reduce this heating of the land, which then results in weaker monsoon winds and thus weaker rainfall. In the new study, researchers found that while reducing aerosols generally strengthens monsoon circulation, the impacts vary across regions due to atmospheric connections. So cleaning up just India's air pollution would increase India's monsoon by 0.19 mm, while cleaning up the world's air pollution would increase it by 0.28 mm. Most importantly though, the study found that if India does not clean up its air pollution, but China does, it might have a negative impact on India's monsoon. This is because of the way wind circulation and monsoon patterns work. And the study said that this cautions against uncoordinated country-specific pollution plans. Countries should instead plan to reduce air pollution together. Next up, the United States Center for Disease Control and Prevention, CDC, is investigating several outbreaks of cyclosporiasis, which has affected more than 400 people across Michigan, Ohio, West Virginia, and Kentucky. Health officials have not yet identified the contaminated food that is responsible, and they are interviewing patients about what exactly is it that they ate before they fell ill. The CDC said that cases have risen sharply since May, and they believe that the true number of infections is likely much higher because many people don't seek medical care or get tested. Cyclosporiasis is caused by the parasite Cyclospora, and it typically leads to prolonged diarrhea, loss of appetite, stomach cramps, nausea, and fatigue. Usually, previous outbreaks of this disease have been linked to fresh produce, fruits, and vegetables where the parasite thrives. However, the CDC and the US FDA are continuing efforts to identify the outbreak source and have not confirmed anything yet. Finally, a new genomic study has revealed that all modern koalas descend from a small ancestral population that survived a near-extinction event around 100,000 years ago, long before humans arrived in Australia. Published in Molecular Biology and Evolution journal, this study challenges earlier theories that human arrival is what triggered the koala's first major population decline. Researchers from the University of Sydney and Texas A&M University found that koalas underwent a severe population bottleneck around 60,000 years ago by conducting genomic history studies. The reason for this decline was likely climatic changes during the late Pleistocene, including glacial periods, increased aridity, and habitat loss. As conditions improved, the surviving eastern population expanded and it eventually split into 5 genetically distinct groups that gave rise to today's koalas in Australia. The findings could help guide conservation efforts as modern koalas face habitat destruction, bushfires, disease, and other human driven threats. That's all we have for you today. Thank you for tuning into The Print.